Well, hello, my name's Chris Barkin. I want to welcome everybody to the William W. Hay Railroad Engineering Seminar. Before I introduce our speaker, I'd like to take care of a few housekeeping items. First of all, if you have a cell phone, please turn it off or turn it to vibrate so there's no sound that will interrupt the speaker. If we have a fire alarm, we'll exit from the doors on either side of the room depending on circumstances. If we are exiting from that door, we'll just go across the lobby to the stairs down to the first floor and then exit the building. If we need to go this way, there's stairs right down the hallway on the right that I think most of you know about. Please use the buddy system, so make note of who's next to you and make sure that they get out. We'll gather on the other side of the road and watch out for any arriving emergency vehicles. The other possibility, although no forecast today, is of course severe weather. Similarly, we will go downstairs, except we're going to not go down these stairs on the outside of the building. We'll go to the stairs behind this wall in the old part of Newmark Lab. We'll descend all the way to the basement, which is a very safe location in the event of severe weather. If you didn't swipe your ID or sign in for this, please be sure to sign the attendance sheet that'll be passed around, including your name and affiliation. If you did not receive a direct email announcement of this seminar but would like to in the future, please legibly include your email address on the sheet. I'll ask the speaker, depending on whether we can get a microphone to audience members. If we can, we'll let them ask the question, but if not, I'll ask you to repeat the question so the people online can hear what was asked. The William W. Hay Railroad Seminar Series is sponsored by the Rail Transportation and Engineering Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, I thank AAR, BNSF, CN, Hanson Professional Services, and the National University Rail Center of Excellence for their ongoing support of RailTech and this seminar series. It's greatly appreciated by those of us here on campus as well as those participating via the internet. And I'd like to welcome the more than 100 people who registered for this seminar. They hail from 8 countries and 4 different continents. So yet again, it's another international audience for your presentation, Mike. The list of attendees includes freight and passenger railroads, transit organizations, federal and state DOTs, engineering firms, universities, research organizations, technology developers and suppliers, and others. We're very pleased that you can join us today. Those of you who wish to receive PDHs for your participation, please see the instructions in the email that you received announcing this seminar, or go to our website and you'll find information about it. Mr. Cleary, our speaker today, is going to be addressing again the topic that we're spending the entire semester focusing on, which is the challenge that the railroads are facing in terms of improving energy efficiency, considering alternative energy sources, all with the objective of ultimately decarbonizing railroad freight transportation, and for that matter, all forms of rail transportation. It's a big challenge. We've heard about it from several previous speakers, and Mr. Cleary, our speaker today, has been one of the leaders speaking to the industry about how we need to develop a more organized and coordinated effort to do so. He's a highly qualified individual. He's a veteran of the rail industry with over 35 years of experience in multiple facets. He's currently with Alstom Transport as their Director of Business Development for North American Locomotives. He spent time working for short lines, Amtrak's Class 1 freight railroads, as well as suppliers GE and New York Air Brake. He's also a former FRA certified locomotive engineer and brings a unique perspective to the decarbonization effort. He completed his BS in Transportation Economics at the University of Wisconsin and an MBA in Finance from Texas Christian University. I'm very pleased to introduce Mr. Michael Cleary, who will present his seminar entitled Elements to Consider on the Path to Freight Rail Decarbonization.
Thank you. All right. Thanks, everyone, for having me. Don't hold it against me. I went to Wisconsin. I know you guys live with animosity there, but nonetheless, another Big Ten university. They all seem to be very good. What I'm going to talk today about are some of the elements, I think, more from a commercial and I'll say sales standpoint of trying to get our ideas of rail decarbonization into actions, into products. Right? We can all talk about products themselves and what those products look like, but there's a lot that goes into getting the product to a place where it gets commercialized and you get railroads to accept it and to implement it. And that, I'll try to explain here, is kind of tricky in the industry in terms of what we're doing and how we're doing it for a lot of different reasons, but we'll talk about that as we get into it. I just want to give you a little bit of background on Alstom in general, just so you know who I'm with and what we're doing. And so we'll start with that and then we'll move into the rest of it. Alstom's a relatively large organization in the global marketplace. We don't do as much here in the States as we otherwise might have in the rest of the world, but you can see we are a global presence. The rail freight market, I guess rail in general, but in freight in particular, really is a big difference between the States, North America, and the rest of the world when it comes to freight. You know, passenger-wise, we're down quite a few notches. Freight-wise, more or less, we're at the top. And those two things can get melded together in certain respects, but in others, it's uniquely separate. We are very committed as a European organization to trying to move the whole industry toward, I'll say, the path toward green. You look at this as the green tree and what we have, the roots and what we're growing and what we're doing and what we're trying to come up with. We offer products around the globe that are in virtually every category of green that we currently know of. Right? We have people committed at the bottom to developing the various different components in the products and rolling them up into the various different pieces that we see as being, I'll say, the drivers around this. And there's a lot of different buckets here, right? And different countries do different things and different regions, and it's involved. But nonetheless, we are committed to trying to get this to work because there are so many different paths, and I'll get into that, and that's what I'm going to talk about. We have different things going on in different places. As you're aware, we're not that far along in the path here in the States. It's moving forward, and there's a lot of interest, but there are definitely other regions of the world that are out in front of us in a lot of these different things. Here's what we do right now. You can look at what we have. We're the first in the hydrogen. We have batteries operating. We have electrics. We have hybrids. We all know the world is looking for an alternative to diesel. What that is going to be remains to be seen for many different reasons. But we do them all now. I'm not going to get into the details of what we do and how we do it, but we do have the ability to do things. I think some people in the next couple slides will show you, we do some things that surprise some people sometimes on how we're doing stuff around the world. And in particular, it's the heavy haul stuff. You know, when you think about Alstom and you think about the rest of the world, there are a lot of passenger trains. You know, not so much here in the United States, but there are a lot of passenger trains around the world. But there are also a lot of freight trains. And we build some of the largest freight locomotives in the world, albeit electric, but nonetheless. I bring this slide up to show people and to kind of level set about what we have going on in terms of a portfolio. And the reason I bring it up here for us today is that we build very large locomotives that are compatible with what the needs are in the United States. The freight environment in the United States is the most demanding, I'll say, of any freight locomotive market in the world. We run bigger trains with heavier axle loads faster than anywhere else on a consistent basis. I mean, there's places in our country where major mainline points, you're seeing 50, 60 trains a day, of which they're all in excess of 8,000 tons. And there's nobody else in the world that really runs that frequency and that size. But we have the capability, as things progress, to be able to support some of that, although in a slightly different format with a different form of energy, but nonetheless, we understand that market. We also do a lot of different things other than those big locomotives, and we are the only ones right now in this country that operate a dual mode locomotive. And I don't know if anybody's familiar with those dual mode locomotives, but what you have right there on the left is an Alp locomotive, dual mode at New Jersey Transit. That locomotive has diesel engines and catenary. The only type in transformers operated via the catenary. The only type in the country with that, where that train can sail off the end of the catenary and convert over to diesel and keep on moving. And that's how they use them every day. Right? The only ones out there. And I bring that locomotive up because I feel that what's happening in the future is going to have to be hybrid of some type, at least initially, until we can get infrastructure around what we need to do. But that's why I show that locomotive, because they already exist. People are surprised to know that these types of dual locomotives exist. They exist and they operate every day. So we are going down that path, and we're actually on the path with other than just conceptual or prototype locomotives. We have revenue service locomotives. Locomotive on the right, that's not AI generated. That is what a locomotive we build actually looks like, and as you can tell from the coupling system and a few other hidden features there, it's European. We do a lot of different types of locomotives in Europe. The way locomotives are sold in Europe is distinctly different than they are here. If you've ever seen the Jane's Guide to Railroad Locomotives, Jane's does the guides for military things and lots of different industrial equipment. The Jane's Guide for locomotives is about 1.5 inches thick. And it's like, wow, how can there be this many types of locomotives? There are locomotives for all kinds of types in Europe, and they're all what I call small batch builds, 30, 40, 50. We don't do that here in the States. We build locomotives, and when I was at GE, you design a locomotive and you offer it up, and you're selling hundreds, if not thousands of that type. That's not how the rest of the world works. The rest of the world works on almost product-specific, use case-specific locomotives, of which we have locomotives we build that have 3 axles. I don't even really bring that up that much, because when you bring up 3-axle locomotives here in the States, people look at you like you're crazy and it's some kind of Lionel toy train, and we're never going to use that. But that's one of our hybrid locomotives, of which we have several different types of hybrids. But we have the ability to do that. One of my roles is to take that type of locomotive and that technology and figure out how to repackage it and put it into something that can work here in North America. Because what works there is distinctly different, especially in freight, than what works here. Before we get started on the paths, I want to talk about a couple variables and assumptions and the conventional wisdom that's out there, because there's a lot of different people that talk about this. And there's a lot of, I'll say, ideas that get thrown around, and I'll say truisms that may or may not be true. They might have an element of fact to them, but they don't apply the way people think. And the other thing I want to clarify is, when we start talking about the different solutions for locomotives here in the United States, you really have to be cognizant of the fact of, are you talking about a road locomotive? Are we talking about a yard locomotive or a road switcher? They have very different needs, very different use cases, and you have to look at them distinctly different. And you get stuff commingled, you start talking about it, well, it'll do this, it'll do that, but you really have to clarify at each step what type of locomotive you're talking about. The one thing I will bring up is that the emissions, and if you're going to make a dent, you have to figure out the road units in this country. That's about where 90% of the emissions come from. The big stuff that's going fast for long distances, that's where the fuel and that's where the emissions comes from. But where you're going to need to start is not there. It's going to have to start with the smaller locomotives to prove out concepts and to get faith and to build trust and to show that the technology is available. Another thing I think that is worth mentioning is that this country is and has been very much centered around interoperability, and it's a great thing. You can take a locomotive and it can start someplace in the far reaches of Canada and it can end up in some place in Mexico, and there's no issues, right? It can go across borders, across railroads, across everywhere. It can get fueled the same, it can get maintained the same. Somebody that speaks one language can get on the locomotive and understand exactly what it needs to do and get on that locomotive and then fix it. I feel going forward, we probably will get away from that to a certain extent. The interoperability thing has been worked on for years. And it's even gotten to the point where the fuel filler for all of the locomotives in the country, it's standard. One fuel filler, almost everybody has the same exact fitting to be able to put locomotive into the fuel, put fuel into the locomotive. The differences that we see moving forward with the different types of technologies are going to change that. I truly believe that we will have pockets of locomotives that will operate one way or the other. And that, what that does though is it creates some inefficiencies, right? And the railroads are all about efficiency and what they need to do it better. The level of interoperability will change, And whether or not that decreases efficiency remains to be seen. But there is some things there that will have to be looked at to understand how do we do this. And I think our thinking on it's going to have to change, because for the longest time in the industry, it's like interoperability, that's what we have to do. We might have to revisit that a little bit. Another thing we're going to have to look at, and we talk about this, is energy supply. We are a vast country. There are lots of things out there. Lots of energy types, I should say, that are out there, right? What are we going to do where? You know, certain of the energy types going forward need a lot of water and or a lot of electricity. Right? How are we going to get that to places that are, I'll say, off the beaten path? If you look at what's happened in the rail industry, the major refueling points on the big railroads, where they've had decades to refine and get straight, they're located in particular, because it's a diesel world we live in right now, they're located right where diesel pipelines are, at the end of them sometimes. The largest single point in the world for diesel fuel, I'll say fueling, is a very small town in New Mexico. They pump more diesel fuel in a small town in New Mexico than any other place in the world on a daily basis. It's amazing, right? How is that going to look in the future? Don't know. But these things where we have everything concentrated are important for the railroads, because they have developed their operating plans to be very efficient like that. And whether or not that stays that way remains to be seen. But what's going to happen is you're going to have different places doing different things with different types of fuel. And that's a significant factor to think about, especially if you're on the railroad and somebody's proposing these things, because you have it dialed in pretty tight. To change that now, and I'll get into this in a little bit, creates some hassles. It creates some headaches for people. And right now, there's not a lot of incentive to do that, right? You have to make this stuff be pretty low impact. And some of these things, at least for right now, are not as low impact as we might otherwise like to think. We also have to think about some of these general concerns about X is too expensive, or Y is not feasible, or this is not the way it should be. There's been a lot of just, I'll say, the mindset on things over time has developed in certain ways, and I would ask everybody here to think about those things, because it's changing, right? Some of this technology is changing. So what might have been true 3 or 4 years ago might not be the same. The fact pattern might be a little bit different. We might want to look at that and say, okay, but what about this? If this new technology emerges and we make that in conjunction with this, we can complement each other and maybe change some of those things. So just think about that as we move forward, with all of you move forward, and we look at these things, because things are changing that way. Another big piece that we have to think about, it doesn't get talked about very much, is that right now with diesel, we know what all the emissions regulations are. They're clear, they're cut, you can look these up, they're federal regulations, they're out there. It takes a while to put that stuff together. Those will probably change based on all of these different alternative fuel types. What are we going to do, and how are we going to do that? And again, it's keeping that open mind, which is what I say there, right? This is, open mind is your best friend to look at this, because as we go forward, keeping things in the back of your head that you thought were true, or you know to be, this is how it's going to have to be, might not be so in the future. Right? Like I say here, it's a multi-dimensional chess game. There's different pieces moving, and they're going to affect other pieces. And knowing that and trying to keep our head around all that is the task at hand. The path to green. I've thrown this up a few times, and it gets a lot of interest, right? I say, and again, this is just me, if you look at the spaghetti diagrams that come out, everybody thinks they have an idea of what's going to happen. We don't know until we know. And I would say, I'd submit to you and to everybody else listening today that we're about day 6. That's my swag on that, is we're about day 6. Most hurricanes dial in depending on when they are, day 2 or day 3. And I think that for each day, we're looking at about a year. It's going to take us a couple more years as technology advances, as we get some prototypes built, and as we see what's happening, to find out which is the path that the industry is going to coalesce around. And the only difference, I'll say, with this diagram and how things are going to work is I think we could have a couple different solutions, right? Mainline might get one solution in some areas. You'll have yards that there's some technology that seems to apply for yard locomotives. And then road switcher technology, the stuff that's not in the yards, might have yet another one. I could see that happening, right? Just in what I know and how things are moving forward. But nonetheless, as you can see, this is an iterative process. This isn't like, okay, we just decided. There's inputs and new ideas and new technology coming in all the time. And the railroads, as they gain more knowledge, their wants and needs are also changing. So it's just moving forward. It's a story that we're all working on. It's a lot of fun. I really enjoy it because we are going to truly make a difference here in the rail industry and trying to get the diesel down and the green up. But nonetheless, it is an unknown point. It's an interesting point, but yet it's unknown. The cone of uncertainty is wide. We will eventually dial this down to, I'll say, 2 or 3 prevailing technologies. Again, these are my opinions on how things are going from what I see. I don't think, diesel and what it did and when we went from steam to diesel, we won't see that again. This is not a steam to diesel transition. This is a diesel to multiple alternative solutions that I think that will prevail. Here's the inconvenient truth. Diesel fuel, I tell people, it's magic. It really is, right? When you look at the energy density of this stuff and the relative price on what we get, and everybody knows how to use it, and it's easy to use. It's just liquid, it flows, you can put it in a pipeline, you can put it in tank cars, you can do anything. It's easy. It's everywhere, right? We don't have to worry about trying to get this to one place to another. It's relatively safe, which is another big one. Some of these things, the safety cases have been written. It is very safe unless there's a few extreme circumstances, but for the most part, it's very safe. It's well understood, and right now it's accepted. If you were to take this, and I almost did that, check these off versus all of the other types of energy solutions going forward, we do not get every box checked like we do here. And that's the reason diesel is staying where it is. I would submit that diesel is around probably longer than some people might think, just because of all of these factors right here. For us to be able to replace all of those factors with one thing, it's very, very difficult. There's one that kind of comes close, and I'll get into that a little bit, but many of these others, it's going to take us many years, right? In particular, I'll just pick out 2 here, right? Safe. The safety cases for a lot of these new technologies have not been built. That takes many years. I mean, we are very good in this country at understanding what that is about. We have specific processes in place. And when you build a safety case, you have a lot of things to answer, right? And regulations are based on that. All of that's known already for diesel. It's known for maybe one other, but the rest, it's a work in progress. To get those things done in a timely manner is very difficult. And when I say timely, I'm talking years. This is a multi-year project for that one in particular, but even for most of these, right? The energy density, some of these we're just not, if you look at any chart we look at, right, depending on what you want to put on the X and Y axis, diesel's always in the corner, and then there's nothing else close to it. That is a big deal, right? If you look at what you can put into a fuel tank, and I think Mike Iden talked about it last week, compared to everything else, it's just tremendous. The efficiency of it is close to what a steam engine is. But because it's so energy dense, you can take it with you and it really doesn't matter. And I'll get to that in a few slides going forward, right? But one of the premises I think is going to have to happen, at least in the near term, is you'll have to look at technologies that bring the charging system with them. And you think about diesel, well, it doesn't bring the charging system with them. Well, but yes, it really does, right? There is so much energy in a 5,000-gallon fuel tank for a road locomotive in the United States. It can more or less go from Chicago to Los Angeles and not have to be touched. That's bringing the charging system with it. Anything short of that, and you can find some places in regional things where you don't have to refuel, but when you're talking about, in particular, like batteries where you have to stop and charge, that becomes a hindrance to the operating system. The operating people don't like that. And we'll talk about that some more. But if you look at some of these things that are understood, the path to get some of these alternatives to where diesel is going to be a long path. Nonetheless, it's worth it, but my point here is that some of these technologies will take There's some ambitious timelines for some of these things, and I think some of those timelines they'll be moved to the right, if you want to call it that, just because of what we have going on and how that works. All right, so let's talk about the major elements, right, to advancing green fertile alternatives. There's a bunch of them, but I broke them down into some of the ones I think are the most important. Again, it's not an end-all be-all, but when I look at how railroads look at what they want to do, you can put these, there's a few more, but I think these are some of the most important, right? You know, I quote, it's an old book, Sun Tzu, you have to know yourself and know the enemy. In this case, it'd be the customer. You have to know what's going on with the terrain that you're trying to battle in, and you have to know what weather is, and that's how quickly the technology is changing. If you can have an answer for those, and know where you're going into, and knowing that things like the weather and terrain are going to change, you can do better than otherwise. And I think that everybody that's in this world has to understand these things. And I think these, and there's several others, but we'll talk about these in particular, and we'll just evaluate what we think, and I'll give you some data points on what these look like. Cost. Depending on where you go, cost is usually the first thing that comes up. Right? Maybe not, but if it's not, it's always in the top three, and a lot of times it's led with that. What's this stuff going to cost me? How does it work? You know, what are the headaches? Lots of different types of costs to talk about. And anybody here is taking an accounting class. Which ones really matter, though? What is your customer particularly concerned about? What is funding going to help us with to alleviate? And how do we get to where we need to be to where this thing becomes viable on an ROI basis? In the early stages, of which I think we still are, but that's starting to wane, there are people that looked at the green initiative as something we just need to do. It's the right thing for the economy, it's the right thing for the world, and we've moved forward with that. The general consensus now is it's changing a bit. And although people always want to do the right thing, and if we could stop burning diesel tomorrow, I think a lot of people would do that, but the trade-off is tremendous. And what is that going to cost me? Is that going to cost me any more long-term, short-term? Where is this going to affect me? And so knowing your costs and being able to explain those is very important. There's only really two technologies now that we know more or less the true costs. The rest of them, the jury's still out because we haven't operated them enough to be able to work on that. And I'll get into that here in a little bit. But getting costs in line and making sure that we can achieve a cost structure that is long-term viable is tricky, especially in some of the stuff we don't know, like in particular, like at batteries. How much better are batteries going to get? Can we answer that definitively? There's lots of papers you can read, and people have different ideas on how much we're going to get out of the battery and how much the cost per kilowatt's going to be, but it moves around quite a bit. It all depends on your battery chemistry and what kind of batteries, what's your charging rate, your rate of discharge. There's lots of different things that cause these battery costs and length of life to change. But nonetheless, it has to be known. And you look at things like hydrogen. What's the hydrogen cost? Now, what are we going to work on? Federal government has a goal to get it down to equivalent to diesel. But that's only the cost to produce it. About half of the cost of hydrogen is in the compression and the transportation of it. So all of these things still have to get, I'll say, ironed out. And again, that takes a little bit of time. Cost trends are important, what I'm saying here. What are we going to do? Is the price of charging, is the price of electricity in general going to go down? Is the price of hydrogen going to go down? And how is this all going to work? There's some unknowns there, and unknowns are not treated kindly. We have to get answers, definitive answers and trends, and be able to prove that before some of these can move forward. How does it compare to what we have now? Depending on who you ask on the various different railroads, that's one of the first things that pops up. Well, I have this now, how does this compare? Well, that depends. You hate to tell people that depends, but it really does depend on use cases and different things, and that's why I say this is a multi-dimensional chess game. When you start to look at the comparison points, well, what do you need? What do you need versus what do you want? You have to, suss that all out. It takes a bit of time, and it's worth it, but again, the underlying theme here is that you have to know what everybody else is doing. That's why I have at the bottom. Comparison is poverty, right? That's that old saying. But here it's essential. You have to know what else you're up against And in particular, what else you're up against in that particular region is the source of a different type of energy, abundant and cheap in that particular area. Are there subsidies by maybe a federal, state, or a local government in that area that cause this type of energy to make sense here, but maybe not somewhere else? And that's why it circles back to what I'm talking about. We might get pockets of places that operate one type of technology versus others. Hard to know, but it seems to be that that's where it's heading. Technical readiness. Let's start from the bottom. If you look at the industry, going first usually does not have big rewards in this industry. We have more or less duopolies, right? If you look at that, in the east we have 2 big roads, in the west we have 2 big roads, and we have 2 big roads in Canada. Getting ahead of it gets you a little bit, but the fast followers are right there, right? And so when you start to get this stuff ready, you have to find people that are willing and have some vision to move forward, because a lot of times the full-on advantage turns into somewhat of a disadvantage, especially if this is quote-unquote science project level stuff where we're having to test and retest and look at things and put them out there and maybe delay some trains. And anybody that's been out there before on a road knows that's the last thing you want to do. You want to have that thing ready for prime time when it goes out. And we know that this technology is new enough that it's going to be very difficult to do that. But some of the first things people ask is, is this ready? Is it robust? Can you actually do this on my railroad? The answer is yes and no. It depends on the product. It depends on your use case. So you have to answer these questions. You want to try to find the location with the lowest common denominator where you can put it all together in a place that won't affect them, that they can learn, and that it is already designed to do. We at Alstom are working on a design where we think, and I think a lot of the other roads or the other manufacturers are also looking at, try to do this stuff at a lower level of energy need, right? Do this in a place where you're not going to get in trouble for delaying trains. Do it off the beaten path with smaller energy levels so that you can refine what's going on and understand it better, so that the ultimate goal being to where I said earlier, getting to that 90% level, which is the road locomotives. But this stuff's going to start almost always in yards and in road switchers that don't need the energy, that we have use cases that we have energy plans that'll suffice, because getting to that level of running mainline road freight trains is a whole different story than trying to get this stuff to run in a yard setting. Addressing all the use cases. I don't know of any application right now that can address all the use cases. And people ask that, okay, well, what's going on? Why not? Well, it's the simple fact of how you look at it. Like, I believe Mike Iden talked, and he talked about diesel fuel and he talked about batteries. Right now, batteries are good for about 1/10 of what diesel fuel can put onto the same locomotive. You're not going very far if you have 10%. Now, you can make a difference, there's no doubt about it, but if you're, and I'll get into this in a few more slides, if you're looking at how you want to do this, having to change out tenders with batteries is onerous at best. I'll say it's a showstopper for a lot of roads, especially in the mainline environment, but testing them in a yard environment that's not bad. In our industry, everybody wants to know, who else is using this? Where else do you have this? People don't want to be first. Again, it goes back to this being early. Unless you find just the right visionary that really wants to do something with you, you have to have, and it's so hard to do, is to crack the nut. Where's the first place you can put this in operation? If you can get it in operation with one, that's a big deal. You treat those people well and you give them all your attention. Because proving this stuff in an industry that doesn't have a lot of, I'll say, gumption to go forward with being the first and get out in front, it's hard to do. Once you have it running, they always want to know what's going on if it goes down. If you look at freight locomotives and the fact that we have freight locomotives operating Class 1 railroads today that are at least 50 years old, there's a reason for that. Those things are, I'll say, bulletproof, right? Everybody knows how to fix them. Everybody knows where the supply of the parts come from. You know who to call if it goes down. And in many cases, you don't have to call anybody because you know enough about it that it's fixed by your own people quickly. And that's a big deal, right? Also, parts. You know, you start something new, you have to keep it closed in, right? You can't have, okay, we're going to go here for parts, we're going to go there for parts. But again, the advantage that we have in this industry now is that all this is known. Everybody knows where to go for parts, they know how to do it. It's all there. The other piece is that longevity, right? You look at the two suppliers, and what you have in this industry, it's relatively small. And I'll talk about this in another slide, that we don't have the volume of the trucking industry, and we don't have the margins of the airline industry. We're kind of like stuck in this middling spot. And when you have things like that, you get exactly what we have. The economics of it say we have duopolies. We have two suppliers for most of the major components of things in freight railroading. You have two major manufacturers. You have two manufacturers of air brakes. It goes on and on. There's two manufacturers for most of this. A third entrant is very difficult to get into this because the market isn't that big and the barriers to entry are relatively high. That's changing now, much like the automotive industry, right? Where when you get rid of the engine, which is a big impediment, the prime mover, what they call in the industry, if you don't have to design one of those, you don't have to spend hundreds of millions of dollars. So you look at what everybody, Tesla, Lucid, all these outfits did. When it's all by wire and running batteries, your barriers to entry come down. It makes the car, I'll say, in some sense it's more technically complicated, but in others it's much simpler. There's far fewer moving parts in an electric car than there is in a diesel-electric locomotive. And so when you look at what's going to happen in 5 to 10 years, right, the players that get involved, one of the big concerns at railroads are you going to be around in 5 to 10 years, right? Because they know that this has been tried before by multiple different people, even as recently as 5 or 6 years ago, right? They don't have the staying power. The technology doesn't last. They don't have the ability to support it the way they want. The part supply isn't there. All of those things come in, and when you look at it, you can see why we end up where we are with two. That's changing now for sure. I really do believe there'll be 3 or 4 here within the next 3 to 5 years, just because of what I said about barriers, technology going down, especially somebody like ourselves potentially, because we are a big player in the rest of the globe. So we have a lot of those, we understand supply, we understand safety cases, we can do that, we just have to transfer that technology here. Operational fitness. Can it do what you say it's going to do every day? All day. You get a lot of things, a lot of people, and a lot of products that we say yes. And that was on the test train. And the test train ran once, and we had technicians on it, and then it came back. But when you're looking at a place in the United States, in particular any of the big main lines in the east or the west, and you have 30, 40, 50 trains a day, they all have to be able to do this, not just one. Transition is another big piece of this. How do you go from 1 train to 2 to 10 to 20? Big deal. But where it starts with is, can the locomotive do this every day, all day? And because the road locomotives require so much more attention and use so much more energy, starting with yard locomotives and starting with road switchers and the stuff that stays close, comes home every night to the same place usually, is a much easier path to prove things out. Because people want to know that, and in particular the operating guys, right? They want to know about what can this do for me. Because what you find in the industry is that mechanical people usually buy the product. Operating department are the people who have to live with the product. And engineers and conductors are the ones that really have to live with it and make this work. And I've seen cases, you bring a new product out, trot it out, and it's the greatest thing, but it's not set up correctly. Engineers or conductors don't like it. And you really, as a manufacturer, you have no control over that. All of a sudden, it's bad order. Oh, I was a bad order. I don't know, we're not sure. We got to bring it in. These things start to snowball. You have to be cognizant of what's going on and who is operating and dealing with this locomotive on a daily basis. Because if the hassle factor is too high for the new technology, they're going to find a way to not deal with it, right? They will. I've seen this multiple times happen in my career. You don't want to be on the morning report for the train holding 4 because your locomotive didn't work. That is just an absolute no way. This is just bad news because the whole railroad knows about it, and you have to avoid those types of things. Like I mentioned, it's got to be scalable. Okay, we can do it for 1 or 2 trains and we have technicians on it. Okay, but now if we want to build this thing out, can this thing support 40 or 50 trains? Is there much more time taken? If you look at what it takes when a train comes in right now to a major refueling point on a mainline station in the United States, more or less that 72 megawatts right in there, 75 megawatts that you can put to the rail, you can do that in 20 minutes, right? Replicating that is virtually impossible with all of the other technologies, less one. But that's what you have to head toward, because otherwise people are like, we're waiting. And I'll get to that, right? The railroads are a service industry. You don't think of them that way, but they really are. They just provide a service. There's not a product. The unit of production is the freight train. If that freight train is getting slower or faster, that impacts the network. We have to understand that. And in particular, new technology like this tends to slow things down. And railroads won't stand for it. They just won't. The velocity of that train, even by a mile an hour on the network, means multiple locomotives. Like 80 to 100, depending on the road, depending on how you want to cut that. If you lose your velocity, which is a measure that they take every day, what is our system velocity? If that drops by a mile an hour, there are people that are up in arms because that means a lot of extra cost for the railroad. Making it pretty is great, but like the old timers will say, paint, don't pull. Everybody wants to get on a nice, clean locomotive, but that's the last thing to do. You make it work first, then you make it look pretty. And that's what has to happen here. There's just no way around it that if we don't have operational fitness as a key element of what you're trying to do and understand what the railroad wants and what that means to them, and each one of these is different, you have a very difficult time at moving whatever that product is forward. Funding. Nothing will happen without funding. I can't overemphasize that. We have a big advantage here in this country. Tremendous compared to the rest of the world. I don't know how many of you are familiar with which types of grants are out there. I just put up just a few up there. The most recent funding from the FRA called CRISI, which is Consolidated Rail Infrastructure Safety Initiative, is $2.4 billion. That's a lot of money, right? We have to take advantage of that because the roads at this point in time, large or small, cannot afford to fund this on their own. They just can't, and they won't. And so we have to understand funding. We have to understand the funding cycle, right? When is the money, when do you have to apply for the money? How long will it take for the answers to come out? Because making sure you line up with the funding cycle is critical to success. Back in the day before the internet, small businesses always had to line up and make sure that they were going to get their ads into the phone book, into the yellow pages, before the phone book came out, because back before the internet, you had to get that book out and look through and find, okay, who are the companies, locksmiths, whatever it was. If you missed that and you had to wait a year, you were in trouble because nobody knew about you and there was no way to communicate this. Same thing with this funding. If you're looking at how you want to move this forward with the least amount of time possible, if you miss a funding cycle, it's another year. And that's a big deal because lots of things change. Your costs change, production, all the people that you got involved and coordinated with, it all changes too. Not only at federal level, but there's state and local funds that are available, and knowing that and getting people together to understand that, because they can be stacked. You can't combine federal funds with federal funds, but you can combine federal funds with state funds and local funds. Big deal. Because the more funding you can get and the more people you get behind your project, the more likely you are to succeed. And with this, you talked about, it's not going to last forever. This window we have is going to last for probably another 3 or 4 years, depending of this, I'll say. And there might be more coming, right? But these are going to sunset. Maybe more will come behind them, but there's a tremendous bubble of funding that people are looking at now to capture. Capturing that takes work, it takes cooperation, it takes coordination, it takes patience, but it takes looking at the different places that we have. When I say places, I mean entities. It's like research organizations, academic organizations, looking at the industry itself, the railroad. Getting people to talk about this in a way where you can find the right partners is tremendous, because going at any one of the entities, in particular a railroad or a OEM supplier, going it all alone is not going to win. You have to get others involved. That's one of the things I've seen. We're not doing as much of that as I'd like. I think there can be more of that, and as Professor Barkin talked about, it's something that I'm trying to push for. How can we collaborate more with the various different people that are doing funding and the railroad and entities like economic development associations that this can bring jobs to? Bring those people together to help this move faster, because this whole idea of understanding where federal, state, and local taxes, local funds are, is difficult. It's just, again, multi-dimensional chess game. All these things are stacked up. You got to get them figured out. Time to market. We talk about how you're just going to build that and then get it out there. This stuff never goes faster than you think it's going to go. It always goes slower. But if you look at what's going on in the rail industry now, we're in this prototype phase. There's been several of those built of various different types, and they're all getting tested, which is absolutely necessary. Right? You have to build the safety cases based on that, get your waivers, move all those things forward. The next step is pre-production. Once you get those locomotives out there and tested, or whatever type of technology it is, you get them tested, you get them brought back, you make your adjustments. There's always adjustments to be made. You got to build some pre-production locomotives, the ones that the railroad gets and the supplier says, this is what it's going to be when we go into serial production, but let's just shake it down. There's nothing more important than shaking down products in the real environment that they're going to be used in, because there are always things that pop up that people didn't realize. Oh, we needed to look at that. That's a great thing. It's just, it's necessary, right? But then serial production. You look at, once we get through those things, serial production, especially for new players, they have to develop the production capacity. What are they going to base their production capacity on? How much demand is there? How's that going to look? Takes a while. How many years? I get that question asked a lot. That is very difficult to tell. But I would say that, until we understand things, we're at probably 3 years on my hurricane thing, 3 years more to understand which of the products. We'll build those prototypes, get them tested, pre-production for another year after that, and then you start the serial production and ramp up. How quickly can you ramp up to a level that makes a difference? 500-600 locomotives a year, that's probably doable. But even that, how many years? You can just do the easy math. Even at 1,000 locomotives, we're talking 20 years, right? So this is long-term. Locomotives are extremely long-lived assets. They've been around a long time. They can get rebuilt. They can do things. It's how it is. The macro and micro approach. Looking at the industry in general, we can learn some things. And we have to learn some things, right? What are the things that help or hurt the industry? How can we put products forward that help everyone? But once you understand that macro level about the industry itself, learning the nuances of the particular railroads is very important. Understanding their people, understanding their culture, what are the operating characteristics and silos of influence? What do those do? When you have a product, you're trying to shop it to as many people and see what the consensus is among as many people as possible. And when you can find people and a culture and operating characteristics, they have vision that match up with what you're doing, that's where you have to concentrate your effort. Because you can't spend time with everybody doing everything. You have to figure out a way to concentrate your effort and make those things come together in a way that makes sense, right? Because again, we're talking about speed to market. Everybody wants to see this happen sooner. If we don't have a coordinated effort, or if people and OEMs and railroads don't have a coordinated effort on this, we just take a while. It takes longer. It's just what it is. Engagement. Engagement, I left it for last and I kept it the simplest because this is probably one of the more complex ones. But understanding the elements to do a deal with railroad suppliers, the regulators, the researchers. Everybody has a slightly different idea, maybe a slightly different agenda, maybe not. But trying to match up with those people and collaborate with them is critical. We don't have a lot of that I see. There is some pockets of it that happen, and you see products that move forward because of that. But understanding those elements and trying to get more people involved to where you can build up the consensus, yeah, this looks like the right way to go, and this maybe not so much, right? This industry is small, 2 degrees of separation, right? You have that 7 degrees of separation to Kevin Bacon. This is like 2 degrees of separation. You don't know them, but you know somebody that knows somebody that knows them. And working that and understanding who are the people that make sense to involve and to bring together, it's big. Because again, when you take that with the other elements and you have them all work in this chess game, you really can make a difference that way. But it's aligning those things. And some of it's just luck, you know, the stars aligned and we had a meeting here and these people are doing this and they brought us in and, you know, and that's great. That's a great feeling when that happens. It doesn't happen that often, but it does happen. But the wider net you cast, the more likely that stuff is to happen. So, in thinking about that again, not a lot on that slide, but knowing all of those things and bringing them together is a critical element to making this work. So those are the major elements. I do want to talk about two things that I get asked a lot, right? There's two things when I talk to people and I'm out there. The first one is, okay, so what do you think is going to happen? Good question. Let's start from the bottom. Famous quote, Mike Tyson. Everybody has a plan until they get punched in the face, right? It's true. You have a plan, you're going to do this. And you hear this a lot. Yeah, we're going to go, but there's some major element that they run up against, bang, they're stopped. What are we going to do? Are you going to pivot? Most people try to pivot, right? But more of those previous elements you have, the better off you are, because and the sooner you find out, the sooner you get punched in the face on this and know, man, I got to really deal with this, the better off you are. But what I see happening in the industry, right? Pandemic and pre-pandemic and into the pandemic, this whole green initiative was really, really a big deal. Moving forward, it's going to happen. Like a lot of things, it seems like the pandemic, things have backed off on that, right? The green premium was an easier, I won't say sell, but a persuasive point a couple years ago. Now it's falling back to more, okay, what are the economics of this? What's my return? How am I going to do better with this? Can this help me save money? Can this improve my operation? You got to understand that stuff. You got to be able to explain it to them, because if you can't, the green premium will not carry the day. One of the big things I see emerging is total energy consumption, right? How much energy am I going to use? If you can find things that use less energy than what it previously was because it's more efficient, it's a big deal, right? Because energy is just dollars. I don't want to have, if I have to buy energy and my total energy consumption, regardless, is less, that's going to win the day. One of the bigger ones. Another one that we don't talk about much that is definitely increasing is the infrastructure. Right? Okay, you can build a product, and the product works fine, but what do I need to support that product on a daily, weekly, monthly, yearly basis? How will that change what I'm doing? That has not been talked about quite as much. It's just like automobiles, right? People have Teslas. Well, the nice thing about Teslas, you can plug them in your garage. Well, you can't do that with locomotives. You got to have a charging station. You have to have the substation to provide the charging station. You also then have to have the energy production itself. Where am I going to get this energy? If you want to take the diesel fuel that one of these places, major fueling locations in America pumps, and turn that into electricity, there is no way that that location can support that amount of electricity without a multi-million-dollar upgrade to the infrastructure in the location. There just isn't. Energy distribution, how's it going to get there? This is something that's very interesting, I think, because there is one category here that we might be able to answer that question, right? Railroads they're the largest private contiguous landowners in the country. You don't have to go and talk to every rancher in the West or every landowner east, can we put some high tension wires? Like, no. First answer is always no, and then starts the environmental impact, and this is years. But if you go to a railroad and you can produce electricity someplace near their tracks and you can get them to buy on board and use their right-of-way to transport energy, you have something. You have a true public-private partnership. And it lends itself then, if you're already going to put up these wires, why not use these wires and take some of the power and maybe run electric trains underneath the wire? It's an idea. It's slowly gaining some momentum, but it's out there, and the others don't have that. Time will tell. We got to get to day 3. Everybody's working on things, collaborating, funding, all of those things. We're at day 6, roughly. I think 3 years we'll be at day 3. Things will have coalesced a lot more around what is happening. So that's where I think we need to get to really make some informed decisions on how this might look. The other big question I've gotten recently Tier 4. Tier 4, if you guys are familiar with it, that was supposed to be the, I'll say, catalyst for green initiative from a diesel perspective. It went into effect in 2015. There's been very few locomotives built since then. And there's people that are miffed as to why didn't the railroads do this? Are they just trying to shirk their responsibility? And I can tell you the answer is no, they're not, right? But what has happened is, if you guys are familiar with scheduled railroading, the whole concept of scheduled railroading, that more or less can be boiled down to run a scheduled railroad, but run bigger trains less frequently. When you run bigger trains, you don't need as many locomotives. When you run a bigger train and put distributed power on it, right there your fuel savings is in the 5 to 6% range. That's a big deal when you're burning millions of gallons a day of diesel fuel. So scheduled railroading in and of itself helped, right? It helped them to save fuel and get toward their fuel economy goals. But what it did also is it created surplus locomotives, right? So I put up there, there's 3 reasons that lead to 2 separate factors, but it's circular, right? The reason 2 is decreased coal traffic. As we continue in other areas of the economy, for environmental purposes, we're getting rid of the coal-fired plants, the railroads were the primary users or transporters of coal. It was a big deal for them. And if you look at any of the charts, you can look at their coal production and coal transportation continues to decline. And so between now and 2030, we're about 8% a year it's going to drop. That's a lot of coal each year that doesn't get moved. Those trains are some of the heaviest trains that continue to operate in the United States. When you take a train out of service, you're taking out at least 3, sometimes 4 locomotives per train. Again, surplus locomotives. Which leads you to reason 3. Tier 4 was costly. It's just, they're more expensive. They are not as reliable, and they use a little more fuel. So when you start looking at this, if you're a publicly held company, to go to the board and request we're going to buy new locomotives of any type, it's going to be a tough sell when you have 800, 1,000 of them stored. And when people look at what the rebuilds are, and there's some significant advantages, or I shouldn't say significant advancements in rebuilding, you can make the older locomotives almost as good from a pulling power standpoint as you can the new ones. So if you can do that for half the cost, your chief financial officer will say, do it all day, especially when you have this whole bucket of surplus locomotives. So when you see what's going on there, Tier 4 just hasn't developed. So, everybody that looks and says the railroads aren't doing their part, it's not quite that. There's some factors that came from the outside that I would think any prudent individual would have made the same choice. Rebuild the older stuff because it's cheaper and we have the cores available to do it. If coal traffic would have went the other way and it was increasing, you'd see a ton of Tier 4 traffic because they need the power. But if you look at the last 4 years, since diesel locomotives were produced, or started in production, there's never been 4 years like this, where there's like virtually no locomotives produced on the domestic basis, like 0. It's unheard of. How long that will last, I don't know. There's a lot more. As coal traffic continues to decrease, the surplus locomotives will continue. So until we get obsolescence at the bottom end with some of the really old stuff, I think you're going to continue to see this rebuild process continue, and you won't have as many Tier 4 locomotives, which are the cleanest, right? That's the best thing we have for burning fuel that we have. And again, it's this industry. Risk is not always rewarded the way it would be in other industries. You don't have foreign competition. You don't have Moore's Law where you got to improve this thing very often or you're just done. So people go with what they know. And so that's why you have what we have, where we are with our existing fleet of locomotives. So that's all I really had today. Thank you for your time. Appreciate it.
We have time for some questions, and I'll start with one if you go back to your last slide. So another advantage of rebuilding existing power, one of my colleagues that I've known for many years here is an expert in pollution prevention. And one of the most energy intensive elements of, motor vehicle, and I'm sure the same is true with the locomotive, elements of their existence is not just the fuel they use, it's the energy that goes into their production. So by not producing, by reusing existing production or existing locomotives, that's a substantial benefit in terms of reduced energy.
Totally agree. About 80% reduction in CO2 emissions when you can reuse the existing steel as opposed to cutting it up and starting over. 80% reduction. New steel, locomotive, everything's made new versus rebuilding what you have. When you rebuild what you have, it's primarily a prime mover and control system upgrade. So the traction motors, everything else just stays. You just make the locomotive better at what it's doing. You don't have to rebuild any of those. You don't have to repurchase and build new any of that. So yes, you're exactly right. It's better for the environment overall when you don't have to build new and you can remanufacture, if you want to call it that, what you have. Absolutely.
Question from the audience?
Come on, nobody? Somebody.
I know we have some questions online too, so we'll get to those.
Hi there. So this presentation obviously was focused a lot on the United States, but Alstom is an international company, obviously working, Europe, all around the world. I was wondering how you think the different situations around the globe modulate these concerns versus, the United States versus other places. I'm sorry. I'm rambling. I mean, Tier 4 is a U.S. standard, which is, and versus, let's say, Europe, where they have a lot of electric infrastructure already. How do you think, how we will go green in the United States is different from Europe? Or I think some of the locomotives you showed earlier were being sent to India or things like that.
Correct. Yeah, diesel electric is so ingrained here that it's hard to change, and it's hard to change quickly. What I see potentially happening is we have to find something that can replicate the amount of energy we use. And again, it goes back to energy density. That fuel tank is filled with diesel fuel is powerful stuff. If you go with that premise, which you have to bring at least for now, you got to bring your charging system with you until the charging infrastructure has been developed to the point that it is not a detriment to the freight train operation. The only one available right now is catenary, because when you have wires strung up, there's your charging system. It goes with the train, right? That's the only one. The rest you have to stop, you have to recharge, or you have to put a tender on board. But the tenders, even the energy density of any of the energy sources you put on the tender can't make it from Chicago to LA. It can't even make it halfway, right? And so now you have to switch the tender off. Well, if you're running 50 trains a day, and let's say every locomotive, just for discussion purposes, it's not exactly that, but let's just say it's a 1-to-1 ratio. You have 50 trains a day and they have 4 units on them, 4 locomotives. That's 200 locomotives. You pick a spot and you're gonna come in and you have 50 trains a day and they each have to have 4 locomotives. 200 tenders have to get switched out. Now, if you've ever spent time in a freight yard, switching a tender in and out on a train on the main line, hour, maybe 2, depending on how big the yard is. Now you have to put people on to maintain the tenders. Is there going to be a switch engine? What do you do about the locomotives that are mid-train DPU or rear train DPU? Now you got to work the train from both sides. Logistically, this hassle factor goes way up. And the time you spent fueling, which you can do the fueling in 20 minutes, but usually when you fuel, you inspect the train. Let's just say it's 45 minutes. You probably tripled that time, right? All things being equal, and assuming that the costs were to be down to diesel, which they're not, now you've just tripled your terminal time for a train. And there's 50 of these things coming. The operating department is gonna go crazy because now the throughput on your, again, freight train unit of production, that's what they do. Your velocity is going to start to drop, and it's going to drop substantially at these locations. And the cost, you have to find land. Where are you going to build the yard to do the charging, right? Typically, half the yards I go to, you have a river on one side and some city road or something. You're hemmed in. So unless you're going to build some facility out, a greenfield facility, again, that takes time to do. It's just, it might go that way depending on what these fuel sources costs become. But the only option right now where you can take the energy charging infrastructure with you is when you string a wire overhead and you're always fully charged.
Thanks for the presentation. I have a question regarding your spaghetti diagram thinking about what are the different options. And you were hitting on that. There's catenary, there could be hydrogen, there could be battery, but there's a lot of hassles with some of those.
Right.
So given your current statement of catenary is the only one that could potentially achieve the goals right now, a couple of years from now, what would those variables be to tip the other ones to potential solutions? How do you increase the energy density of those other?
Yeah, so let me put the caveat in there. We talked about catenary. Bringing the charging infrastructure with you is important on the main line, not so much in a yard, right? If you have battery slug sets, like there is a current Class 1 doing, and their concept is to have a locomotive, and it'll probably have a small prime mover in it, and batteries. And you'll just run around the yard, and when the slug runs down on batteries, you're just gonna run over to the battery charging track, swap out a battery. Very low impact. You'll be able to do that. That's easier to do, and that's totally different than a mainline swap. So in the yards, right, where you don't have this issue of having to worry about so much that the charging infrastructure has to be there for long periods of time, I think there's a case clearly right now for batteries and for hydrogen, if you can get the hydrogen at that location relatively cheap and easy. Again, that transition in one of those slides I talked about with the use cases are vastly different for the main line, and you can also use catenary in the yards, and there's plenty of places. It gets more complicated to use it in the yards, but where I think what will end up going, or people will look at, which is already being looked at, is to use and it gets a little confusing. There's diesel electric, right? That's just diesel with electric traction motors, right? Battery electric people talk about, which is batteries going to electric traction motors. What I see happening is a hybrid electric battery locomotive. You have a transformer in it and batteries also. Right? So if you go off from under the wire, you can run with the batteries, and then once you get back under the wire, your batteries charge automatically without having to take it to a charging station. It's just the wires are hanging above. But to answer the question on what you think will have to happen, I think that if you're going to see hydrogen take off, the price has to come down substantially. Right now, depending on who you ask, it's about 4 times more, depending on where you are and how you make it and what it's from. It's about 4 times more than diesel, right? Batteries, they have to improve in terms of their energy density. Now again, you can do it in yards and things like that where it can come home and you can swap out I'll say the battery packs, which is a relatively quick move, put one over, set and pull another one out. So I think that can happen, but everybody talks about, again, if you want to move to mainline, the battery energy density has to increase substantially. Right? So we'll see. Those are the 2 things I think that would have to happen for those 2. And then the hybrids of those various different types are where I think that a lot of people will settle on, at least initially. And what I see potentially happening is that we might still use diesel engines, very clean, Tier 4 diesel engines, to charge batteries on the locomotive itself. Right? So then you take your charging system with you, even though it's diesel, right? But if you can get that Tier 4 diesel engine in there, which are smaller. So like the big roads, the big manufacturers have big prime movers. There's only really 2, maybe 3, that they use on those locomotives. But when you go to a battery and diesel hybrid, you can go to a much smaller diesel engine, like under 1,000 horsepower, to use it to charge. And when you go to that smaller one, there's a lot of them out there, and they're all Tier 4. So if you go from an existing, I'll say, 1975 built locomotive, and you do this battery diesel hybrid, you're going to reduce your emissions about, again, don't quote me here because there's different things you have to look at, the criteria, pollutants or otherwise, you're going to reduce it in the 90% range, which is a pretty good win to get 90%. The last 10 could be more difficult, but we'll see, we're working on that, but you can get 90% if you go with a modern Tier 4 diesel engine that would be charging batteries, and it could also be used to pull the train for propulsion.
Okay, let's take some of the online questions. First one is, given the power requirements, is it feasible to implement a catenary system for long freight trains currently hauled by 8 4,400 horsepower diesel electric locomotives? And what are the limitations of this?
Yeah, so in my experience, there's not many trains out there where they're going to run 8 units, especially with distributed power. You can't run it at the front of the train because you exceed the drawbar pull of the cars. but you distribute them throughout the train. And when you do that, you reduce the need for them. But you could run, I mean, obviously you have to create substations that can support that, but that is not really a factor. As long as you model and you build your infrastructure for catenary to the size necessary for the trains that you want to run, you can distribute your electric locomotives on a 3x2x2 basis or however you want throughout the train, and you shouldn't have a problem. I mean, it's done already, distributed power on locomotives with electric power. And they're much more efficient, so you don't need as many.
Okay. Next question. How many prototype locomotives do you think are needed to sufficiently shake down new technologies before large-scale commercialization starts?
That's a trick question. I would say that you're going to have 2, 3, 4 of each technology to operate for an extended period of time. Depending on how you want to look at this, are you looking at locomotive years to be able to understand what this is going on? But I think 2 or 3 or 4 of each technology on more than one road, right? So you want to see what these things are going to operate in cold. You ought to have them out for at least a year, and depending on the road and what their topography is and what their climate conditions are. But you'll have to have several locomotives for at least a year, if not 2, operating out there to understand what their puts and takes are, to be able to effectively say, okay, this does work or this doesn't work. And then you also have to look at what it's going to take for the infrastructure to be able to support those in terms of charging and that type of thing.
Okay. Another question from another attendee is, what is the advantage of a battery-powered train compared to a catenary electric-powered train? Isn't the latter more efficient and time-tested?
Latter more efficient and time to test?
Meaning electric versus battery.
Yeah, a battery locomotive is not capable, well, if you're running it in a passenger service or some closed loop system like in a yard where you can go back and out and charge at the same location every day, I think that's completely feasible right now. But if you're going to go out onto the road and you're going to try to go with batteries, you know, right now on a road locomotive, and again, I might not have all the latest information, it's improving all the time, but for discussion purposes, I'll say if you want to put batteries, high density batteries on a locomotive right now, on a standard freight locomotive in the United States, you're looking at, let's call it 7 to 8 megawatts hours of power on a locomotive, whereas a diesel locomotive, that equivalent's about 72. So you're not going to go as far. Now, one manufacturer wants to combine the battery locomotives with the diesel locomotives, which is a great approach, but you're still, depending on how you manage the battery locomotive that's in the consist, it's not going to be able to go as far as the diesel locomotives. At some point, you'll have to switch that battery locomotive out and put another one in, which gets back to the dilemma we talked about of having tenders. You can treat it almost as a tender. It's got to be switched out. And so when it's done, that's when you get the delays involved. But electricity, when you string the wires up, and if you put, one thing that people don't really realize, I call it disco cat, because it's easy to remember and people start thinking that's like just, you got to have mnemonics here, right, that people remember. So think about disco cat, discontinuous catenary. Most people don't realize that there's the technology available now, like in our dual mode locomotive, to pop that pantograph up or down at speed. We can do that at 60 miles an hour. The New Jersey Transit doesn't do it that way, but you can. Catenary, one of the first things you hear, it's so expensive. Well, it is expensive. All of these things are expensive, and I can't wait to see the studies where we come out with what does hydrogen cost per mile and what does everything else cost. But we know the cost because it's been around and it's done in other places for catenary. But when you go to discontinuous catenary, you don't need to have the catenary up everywhere. Once you get that train rolling, the amount of energy needed to keep it rolling is far less than the amount of energy to get it rolling. And so when you have bridges and tunnels, which are very expensive places to put catenary in, you can just skip them, right? You just have the pantograph come down, the batteries take over, and they take us through these spots. And if you're out on the prairie here, where there's no grades barely at all, between Chicago and practically New Orleans, there's a couple hills, don't get me wrong, but once you get the train rolling and you go to battery power, you can go miles without having any catenary. And then you have the catenary again, the pantograph pops back up, it's pulling the train, recharges the batteries, and we go to the next spot. So that substantially reduces the cost that you have to be able to put all of that catenary in. And that's, again, that's one of these emerging things that hasn't really been talked about much, but is a possibility to do to reduce that cost of putting that catenary in.
Okay. What is your benchmark in terms of years for the service life and the design life of a Tier 4 diesel locomotive?
Oh, it's hard for me to comment because I'm not involved with that anymore. But if you look at what locomotives we have out there, assuming you can rebuild the locomotive, which you can, I mean, there's locomotives that are on Class 1 railroads now that are over 50 years old. And it comes down to rebuilding the prime mover, rebuilding the rotating electrical equipment, and doing that. I think that can go on indefinitely.
All right, we'll take just
Yeah.
a couple more.
Got one more in the audience here.
So you mentioned earlier that it would be like 3 to 4 years until a path is set for, I guess, like a solution or like what the industry will go in as a direction. And I was kind of curious, like, let's say hypothetically, 3 or 4 years from now, it looks like it's a mix of battery and catenary as the solution. And so like a rolling electrification program begins. But then 20 years later, some wild breakthrough in hydrogen happens and it becomes almost as efficient as diesel. Do you think railroads will be, I'm kind of just asking your opinion on a hypothetical here, but do you think railroads will go like, okay, we should reevaluate, or they'll go like, there's too much sunk cost into this new system, we got to stick with it?
I think they'll evaluate anything that comes at them if it makes economic sense, right? So if hydrogen becomes something that we've figured out how to liquefy it and use it in a way that is really, really efficient, why wouldn't you? If you're running a business and you can take your inputs and bring the cost of one of them down, a big one like fuel, which is depending on the road, it's number 2, right? If you can figure out a way to drop that down, you're gonna look at that for everything it's worth. So to answer the question, yes, they absolutely will. As this technology advances, you know, the sunk cost, the nice thing about diesel, right, is like the sunk cost is like minimal, right? Because it's just diesel's everywhere, right? So it's just pipeline stuff. You have some fueling stations, okay, and some terminals, but that's about it. So it's a transition that's relatively easy. The transition to diesel was easy, right? Because when you look at what happened with diesel, EMD, which was like the first producers, electromotive division of GM, they promoted in their brochures and things when they marketed diesel engines, you can take your mechanical staff, right? Because a lot of mechanical staffs are set up that way, from 15 people per locomotive to 3. So never mind that the engine was way more efficient in the first place, right? But when you looked at what was needed to support a steam engine, with roundhouse, people at the coal bunkers, people that had to water them, all of those people, it was a lot of people per locomotive. And it was an absolute do it now, how fast can we do it? And even that took years, right, for that to convert. The world's changed now, and I think people look at it and the pace of change has increased. But if something comes along and changes, and it makes sense economically, you know that they're gonna look at it. It's just like any other for-profit business. If one of my inputs changes, one as big as that, they're gonna look at it for sure.
We're at the bottom of the hour, so I think we'll take just one more question from online. And I think it's a good one that you'll appreciate. What are the 2 or 3 most important activities that the entire industry, and maybe I would add government, must agree on to commit to doing as soon as possible to achieve the 2050 deadline?
I think that understanding and putting out the funding sources and encouraging people to look at funding in combination with others is a big one, right? To look at that. I think that if maybe one of the bigger departments, maybe Department of Transportation, was to look at funding specific technologies and getting roads to partner with them on the technology and picking up that tab, I think that could facilitate it. So having somebody on high say, okay, we want everybody to try something. Would you guys be willing to try X? Would you guys be willing? And one road's already doing it, right? So we have some of that already decided. But if they could kind of like coordinate the effort and get people to try this, then we're all going to compare our information to see what's best for this industry. I think that would go a long way, the collaboration of different people. But it has to come from like almost an outside source, because it's hard to do from within, because like I'm listed, you have suppliers and you have regulators and you have funding sources and you have railroads themselves, and trying to herd the cats on that takes a while.
He asked for 2 or 3. Well, I think we'll wrap it up here, and I want to thank you so much for a fantastic seminar.
Yeah, glad to do it. Thank you.